In this video, we're going to take a deep dive look into methods in the Java programming language. In a previous video, I described what a method is, just a quick review of that. So first of all, we know that we have an access modifier, which is the very first word that we see in a method signature. This first line, of course, is a method signature. Then we see a return type. We'll describe why that's important in this video. Then we have the method name. We have any parameter variables that are passed into the method. And then we have the work that the method does. So we'll take a look at this method signature in a bit more detail in this video. And in a following video, we will take a look at the static keyword. So first of all, when you're making a method call, it might be a bit confusing because in our program so far, we've done this a few different ways. First of all, let's go back to driver and take a look. And you'll see here that we're invoking prompt user just by typing the name prompt user, open and close parentheses, and then a semicolon. There's nothing before this prompt user. Now scroll down and notice for your vehicle, we're invoking set gallons of gas onto, but before invoking that method, we have your vehicle and then a period. If we scroll down a bit more, we see there's this show input dialog method. We're invoking that on JOption pane, and then before that, we have an equal symbol and a variable declaration. So you see at least three different ways here that we can invoke a method. Let's describe what those are. The very first type is the call to prompt user from driver. From main. So this type of invocation right here, we start with main. Main is a magic method because it's where all of our work starts in the Java programming language. When you start a Java program, it looks for a method with this specific signature. So that invokes prompt user. Well, it invokes prompt user without any variable or any class before it. That's because it's invoking a method in the same class that it's currently in. So when you're invoking a method locally, you typically don't need to preface it with a variable name or a class name. Now let's look at the second example. The second example is your vehicle.setGallons of gas and .setMilesPerGallon. In that case, we're invoking this method, but the method is a type of method we call non-static. That's the default type of method. A non-static method means that you are invoking this method on an object, and you only want to change the values of that object, or you only want to change the state of that object. In other words, when I put gas into my car, I'm putting the gas nozzle directly into my car. I'm not sharing with everybody else at the gas station. So in that case, I have to choose where I'm going to put the gas nozzle, and in this case, we're referencing that on your vehicle. So, your vehicle is a variable that holds an object. The object is created here on line number 32, and when we invoke set gallons of gas, we're only invoking set gallons of gas on your vehicle. We also know that set gallons of gas is a traditional method, that is, it's non-static. Now, you don't have to put any kind of keyword in a method to make it non-static. That's just a given. So if you don't see the word static in a method signature, assume it's non-static, it's a default. Now, speaking of which, what is the other kind of method call we can have? Well, notice that this one is a variable name.method call, but then this one down here is a class name.method call, and that is a static method. So a static method means we're not operating on a specific object. We simply need to call it in reference to a class. We'll have a separate video that covers that in much more detail. But for now, let's go back to driver. Let's take a look at the JOption pane.showInput dialog. And you might notice that JOption pane is not a variable, it's actually a class type. In other words, we never called a constructor and stored the return object from that constructor into a variable called JOption pane. Instead, we're just using this class called JOption pane, and we're invoking what's called a static method on that JOption pane. Again, don't worry too much about static versus non-static just yet. We will have a separate video that covers that. One other thing I want to point out, though, is that we have something else on this line, and that is a variable declaration and an assignment. So in that case, the show input dialog is going to have some kind of return value that's not void. That means this method will return something when it's finished working. When it returns something, we are going to store that into this variable here called strGallons of gas. You'll see a similar construction a couple lines below where we call double parse double and we're passing in a string. In this case, we're passing in a string that contains a number. double parse double is going to convert that from a string to a primitive type called, to a primitive double type. Now, there's a subtle difference here. Notice that on the left we have the lowercase d double. That is what we call a primitive double type. That means we can invoke methods on that directly. A primitive type is mapped directly to zeros and ones on our storage mechanism. Now, uppercase d double is something called a class type, and it's a specific kind called like a convenience class, because it has a series of methods that effectively do a lot of utility functions for this primitive type. That's not really the focus of the video, so don't worry too much about that, but I do want to point out we have a very similar construction down below as we have up above. We're invoking a method. It's a static method because we're invoking it directly on a class. It accepts a string, and it returns a double. That double that it returns, we're storing into this variable. The variable we're storing it in is called dBl gallons of gas, and that variable is a variable of the primitive type, double, lowercase d double. So a couple of other permutations we'll have, and what I just explained is described on the next slide, where we take a look at what comes before a method. So if we just have a method call like this, kind of like the prompt user method call we saw, so invoking a method but not assigning it to a variable, not assigning the return to a variable, that means the method returns void, or we just don't care about what it returns. On the other hand, we can see something like this, a method call, and then preceding that, we have a variable declaration. The variable is a variable of type int, and the name is value. And we're simply taking the result of this method call and assigning it to that variable. In this case, we have a method that returns an int, and we want to store it into a variable. And the example is just like the double parse double that we saw, or the integer parse int, where this entire method invocation here is going to return a number, and we're simply storing that into a variable. In this case, the method returns an int. Now, on the last example, we have a method and we have an assignment going on here, so that means we're declaring a variable on the left, we're invoking the method call, the method is going to return something, we're going to take that return value and store it into this variable here. In this case, the return type is type vehicle. So this is a method that's not returning a primitive type, but is actually returning an object instance, and we want to store that object instance into a variable called this vehicle. Now, one trick, what if you don't know what data type the method returns? Or what if you just want to make this assignment step a little bit easier? Say you start with a method call like we have on the first bullet point, but you know it returns something, you're not sure what, and you know you want to store it to a variable. There's an easy way to do this in NetBeans. And almost any other IDE, I'm just showing you the example here in NetBeans. In Eclipse, Control-1. In IntelliJ Android Studio, Control-Alt-V will do a similar thing. But nonetheless, let me show you what we're about to do. Let's say that I just have this method here, integer.parseInt str miles per gallon. And I know it returns something, but I don't know what. And I know I want to store it to a variable. In that case, I put my cursor on the parseInt, I hold Alt, and I press Enter. And take a look at the prompt that it gives me. Assign return value to new local variable. So I'm going to select that, and I'm going to name it int miles per gallon. Notice what it did. It figured out the return type, and it's declaring the variable of the proper type, and it's also giving me an opportunity here to name the variable anything that I want. This works on any method that returns something. So for example, if I take out the assignment to dBl gallons of gas here, I go to parse double, Alt Enter, assign return value to new variable, and then I can say dBl gallons of gas. And you see, that saves me a whole lot of effort over typing this all out myself from square one and trying to figure out what the return type is. So from now on, when I'm doing code demonstrations, that's what you'll see me do. So we've had a lot of different method combinations that we can look at here. I've set a couple breakpoints, one on this prompt user method. Remember, we're not calling it with a reference to a variable behind it, so that must be a method on the current class that we're in. Sure enough, it is. Then after that, we're going to come down into this prompt user method, and we're going to invoke some methods on your vehicle, and we're also going to do a JOption pane. So allow me to debug now, and let's take a look and see how this all works. So right-click Debug, Prompt User. Now remember our debug shortcuts. Step into is F7, step over is F8. F7 means I want to see what's going on inside this method. So I choose F7, I step into the prompt user method, I walk over my constructor calls, and each of those constructor calls is going to create a new object in memory. Each object will have its own identity. So you see currently my vehicle and your vehicle, both objects of the same class, so they have the same attributes. Right now all of those attributes are set at 0. First, let's take a look at this non-static method call. Remember again, non-static is the default. That's what we get if we don't put the keyword static in a method signature. Non-static also means that it's operating on a single object and is only going to affect that single object. So your vehicle.setGallons of gas, if I press F7, take a look at the 8 here. Watch what happens to the 8 when I press F7. F7, we've now gone from driver to vehicle. Let me mouse over gallons of gas, and you see right above my cursor is the value 8. That's the value that's getting passed into the set gallons of gas method. So I F8, F8 again, and now we're back. Now take a look in the variables tab one more time, and you'll see that we have gallons of gas is 8, but only for your vehicle, not for my vehicle. If I continue on here, set miles per gallon 20, notice that's only affecting your vehicle, not my vehicle. If I F8 one more time, we see set odometer 30,000. Once again, that's only affecting your vehicle, not my vehicle, because we're invoking a non-static method on the variable your vehicle, which means we're invoking this method only on the object that's held in that variable, your vehicle. Now we keep going, and now we go to our JOption pane show input dialog. Notice that this is a method where we're assigning the result to a variable called str gallons of gas. Now the variable str gallons of gas does not yet exist in our variables tab, but as soon as I execute this line, it will exist. So I press F8, and just be aware in NetBeans, the first time you raise a JOption pane, it tends to hide from you. So here I'll put gallons of gas as 12, and now we'll come back to our NetBeans editor. And let's see what happened after we ran that last line. str gallons of gas now has the string 12. You see it's a string because it's in quotes. Line 49, we're going to convert that string to a double, and we're going to save that into dBl gallons of gas, and you'll see a new variable created here. Remember, when we declare a variable, type and name is what we provide. So we give it a type and we give it a name. And the variable is alive from the point at which it is declared until the closed curly of the scope where it is declared. So these are essentially temporary variables. So I go ahead and choose F8, and sure enough you see dBl gallons of gas, and it's stored to the value 12. We could keep going with this. I'll just go through relatively quickly. Miles per gallon 25, F8, 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 odometer 25,000. And what we'll see is that my vehicle and your vehicle have different values. So for my vehicle, we have, we'll fix that part there. For my vehicle, we have 12 gallons of gas, 25 miles to the gallon, and 25,000 on the odometer. For your vehicle, 8 gallons of gas, 20 miles per gallon, 30,000 on the odometer. As I go through here and I give these a few trips to run, we'll see that each of the objects are affected individually. So first we run my vehicle, and my vehicle's gallons of gas decreases by 2. The odometer increases by 100. And I think we didn't run your vehicle at all in this case, so no changes to your vehicle. So instance methods, or in other words non-static methods, affect only one object in isolation. They're not going to affect all objects, only one object. And that's why we have to refer to them with a variable name so we can tell it which object we want this method to affect. If we wanted to affect all objects equally, what we would need is a static method, and that's going to be the subject of our next video. I look forward to seeing you then. Thank you.